This is lesson 10 AP Calculus, Integration Technique, Use Substitution. This is based on the old kind of adage of when you're given a hard problem, make it easier and then work it out that way. So this is in integrating composite functions, which is where we're going to be doing the chain rule in reverse. So I want us to first think about derivatives and chain rule. So if I were to give you this function sine, but the inner function is x squared, and to take the derivative of it, you'd have to take the derivative of the outer function and get cosine of x squared, and then the derivative of the inner function. So you were using the chain rule. Well, we're going to figure out how do we do this in reverse. How do we do the integration when we know a chain rule has been applied to do the derivatives? So we'll look at that same problem, and I know we know the answer because we just came from that, but if we were just given this, we look at this inner function because we can see that we have this outer function of cosine. This is multiplication, so this is not one function inside of another. This has one function with another inside of it, an outer function and an inner function. So I want to look at the inner function. And for just a moment, take that inner function and call it u. And say, well, what would happen if I took the derivative of u with respect to x? And so I would get du equals 2x dx, which is over here, 2x dx. And so that would be the du. So I can replace that in the integral problem. And now I just have a one function integral. And we can say, oh, I know the integral of cosine u. The antiderivative is sine. So we have sine u plus c. And we will now go back and do the substitution again. And say where I see a u, I put the x squared. And so we have the final answer for this problem. Now, of course, when we did it before, we didn't have the plus c, but that's because we're doing an indefinite integral. We don't know if there was a constant being added. The general idea is to look for this pattern, and that is that you have some composite, some inner function inside of an outer function, and that the derivative of the inner function does exist in that integral. We're looking for that. And we then, in the u substitution, want to make the inner function the u, and the derivative of the inner function our du. And don't forget, it's the derivative of the inner function dx. Both of those things have to be together to substitute in for the du. But what happens when we don't see the derivative of the inner function? And the main thing is if it's a constant, that derivative of the inner function would have to be a constant. Well, here's a problem here, that if I have this one and I've got the inner function is 5x, and I don't have the derivative of 5x, which would be 5. So that's going to say, well, let's just look at this for a moment. If the inner function was 5x was u, the derivative of that du would be 5 dx. I don't have 5 dx. I only have dx. So what if I were to take this equation here, this du equals 5 dx, dividing it by 5, I get 1/5 du dx. So that means wherever I see a dx, like right here, I could replace it with 1/5 du. So in the original problem, I replace everything, and you'll notice that there's my 1/5 du that I replaced the dx with. And now I can take the integral of sine, since it's just a single function, that's negative cosine, and I have the constant out in front, so it's still there. And then I distribute that negative, so I've got here, and then the u becomes 5x because I did the substitution back. Here's another problem. Now this time, my outer function is the square rooting function. My inner function is x squared plus 3. So x squared plus 3 is going to be my u. Take the derivative of u, and it's 2x dx. And I don't have 2x dx, I have 1x dx. So in this equation, divide both sides by 2, and you see that wherever I see x dx, which I have over here, x dx, I can replace it with 1/2 du. So x squared plus 3 becomes u. X dx, well, that's 1/2 du. I'm going to put the 1/2 in front because we like to put our constants out in front and do the integral there of the square root function. And simplifying, we get 1/3 u to the 3/2 plus c. But don't forget, now we have to substitute back in for the u, and we end up with 1/3 of that x squared plus 3 to the 3/2 power plus c. So now, for this lesson, I want you to do these 3 problems. I will post the worked out solutions on the website, but I want you to do the 3 problems first before you check them out.